My name is Jelani Bailey. The name of my project is Optimal Chemical Dispenser. Our team leaders are Ralph, Lucas, and Hamlet. Ralph is our hardware lead, Lucas is our technical lead, and Hamlet is our software lead. So, we walked around LifeSpire facility located in the Bronx for a few minutes. Augie showed us the facility and the people that work there, and he introduced us to a couple of project ideas. None of them seemed to really land with us until he took us to the chemical dispenser that they have at the facility. We noticed that there are a lot of flaws and room for improvement, so we decided to build a new one with Augie's help. We brainstormed with Augie for about 5 to 10 minutes until we realized that this was something doable and it would look good for the facility. So our project was based on efficiency first and foremost. We saw that the jugs were leaking a bit at the input ends, and we figured instead of using broken tubing and damaging the tubing, why don't we create one universal tubing that could fulfill the project needs or the agency's needs. So we went out, got a couple of pumps, 4 of them to be exact, and they all came with specified tubings that would work for the project. So with all these tasks, hardware and software, I figured the best people on our team for that would be Hamlet, Ralph, and Lucas. Hamlet's really good with electronics, so I put him on our hardware team. Lucas is an English major, so I figured he would be best at writing up the manual and even getting us prepared for this little event in SUNY Albany. And Ralph is both good with hardware and software, but seeing how our team lacked the software hand, I needed him to be in charge for both hardware, with both hardware experience and software experience. So originally we wanted to make a product that was both efficient and safe. So coming back to Manhattan College, we all had a bunch of ideas on how we could make this happen. Unfortunately, all these ideas seemed great at the time, but we had no idea what we were doing. So we took that time to go and ask a couple of professors that had experience with this to get us going in the right direction.
So Jay's group is going to have a problem with fully conceptualizing their ideas and being able to make them real. They haven't really been in a good place in terms of being able to identify all the parts and pieces of their project, and it's, as a result of that, it's taken them some additional time to try to pull everything together and solidify what it is exactly that they're doing and how they're going to make it all work.
So initially, our biggest challenges were both time management and figuring out the parts that would make this project work. After much research, we found a touchscreen, pumps, and tubing that would complete our project. Touchscreen gave us a couple of issues. We had to contact the manufacturer and their technical support. Next was the user interface. Their user interface was actually just a button, and we thought we could replace that by using something more modern and software techy by using a touchscreen interface. So we went out, looked at a couple of retailers and vendors for touchscreens, and we picked the best one that we sought for our project, which was an Easy LCD model number 304. And we had some issue troubleshooting it. At first it wouldn't respond or even connect to our user inputs or even the computer. So we contacted trouble support on the manufacturer's end, and they gave us a hand in that. And now we're able to operate the touchscreen just fine. The next biggest issue was communicating the touchscreen to the power supply that we've recently acquired. The power supply seems to be very straightforward. Attach a few relays, send electrical signals in, or actually send voltages in, and get it to run. Yeah. But we ran into some issue actually having the touchscreen to output commands as opposed to just receiving them, so we asked Dr. Gatso's help for that. He referenced us to the manual, specifically the I/O pin layout for the serial communication port on the touchscreen, and we were able to test the serial inputs and figure out how to reroute it to our specific program.
Hi, my name is Hamza Martinez. I am the software lead. The original design is that we have a touchscreen with 3 choices for chemicals and 3 different sizes for those chemicals. Once those choices were inputted, it would send the signal to the Arduino board. The Arduino board would then send the signal to the motors so it can select the correct chemical and dispense it. The problems that we've had have included the unresponsiveness of the touchscreen, the difficulty of the coding program for the touchscreen, as well as connection issues with the development kit, which included the cables disconnecting from each other, and we had to solder it together again multiple times. So after calling customer support, we have been able to fix most of the responsive issues of the touchscreen. We think we have a permanent solution for the cable, as it has not been disconnected recently. Our biggest problem moving forward is probably how well it interfaces with the hardware, because we haven't had time to actually test it with the hardware. We don't know if it will respond well.
My name is Rafael Guida,
My name is Salah Al-Dogum.
and we are the hardware design leads for our project. Our original design was to create a dispensing system with cleaning agents that really you couldn't touch and mix yourself. So the idea was to set up 4 pumps. 3 of the pumps would be conditioned to the solutions, and the last pump would be used as the water to mix the solutions together so that they could be usable.
What problems have you encountered since your original design?
Some of the problems that we've encountered since our original design was wiring. You know, how we were going to wire it all together. There were many different approaches to this, but in the end we stuck to our final schematic, which proved to be the cleanest design and the most
Efficient
efficient
as well.
design.
Some of the problems also how we're gonna connect the electrical with the computer stuff, with the touch screen, and how the coding will communicate with the actual wiring we just did.
Well, first we had to build the housing unit for our dispenser. So that
Took us some time to choose the kind of wood we have to do, and how the size of it, and how we're gonna do the connections inside the dispenser itself, And until now, we almost done with the hardware, with the wiring, with the pumps, with everything. Now we have some problems with a couple of the relays. So, but we are like 90% done with our electrical wiring.
Yeah, one of the problems that we're facing now towards our final results is the relays. These relays are small and delicate, and with the soldering and wire, we have to be very precise with it to not break off any of the pins of the relay.
Well, we believe as a hardware, we finished every single part for the software to do. They have just to plug their touch screen and it should work. I believe as soon as they finish their coding and we want to try to integrate both of them together, we're going to have some problems with the timing issue for the pumps, how long it's going to dispense and these stuff. And but I think we will figure it out once we integrate them together.
Like Sal alluded to, their main issue right now is to test it, you know, get the timing down, get the flow rate down, see how different solutions act with the pumps, and see how the pumps handle each load differently.
In it, we have 4 pumps. 3 are to output concentrated chemicals, while 1 pump outputs water to dilute the chemicals. Each pump is connected to its own relay, which is then connected to the touchscreen. Our demo shows how the system should be working, where the touchscreen switches the relay on, and thus allowing direct voltage to turn on the pump.